there's a protein in the path. So this is active transport, and it costs ATP. That is the most reliable wrong answer in all of Unit 2. Glucose is rolling downhill. The gradient paid for it. The protein never sent a bill. One question decides every crossing here. Not is there a protein? Which way is it going? Here's the setup. A solute crowded on one side of the membrane and scarce on the other. That difference isn't just a pattern. It's stored energy. Crowded is high ground. Sparse is low. Let go and it rolls. Downhill happens by itself because the molecules were already moving. Now start it at the bottom and ask it to climb. Nothing. Uphill never happens on its own. Something has to push, and that push costs 1 ATP. That is the whole definition of active transport. Oxygen is small and nonpolar, so it dissolves straight through the oil. No protein, anywhere. Score every crossing the same 3 ways. Which direction? Is there a protein? How much ATP? Glucose can't do that. Too large, too polar. The oily core turns it away. So the cell supplies a doorway. And watch. Glucose is still going, crowded to sparse. Direction down, protein yes, ATP still 0. It's passive. This is facilitated diffusion. The protein made the trip possible. It didn't make it happen. Opening a door pushes nobody through. New scene. Sodium is already crowded outside the cell, potassium inside. The pump shoves 3 more sodiums out, toward the side already packed with them, uphill, and drags 2 potassiums in, toward the side already full of them, also uphill. Both ions force the wrong way. Somebody has to pay. Here's the bill. 1 ATP. Direction up, protein yes, ATP 1. That's active transport. Notice which row actually changed. A resting cell spends 1/3 of its ATP budget on this one pump. It buys nerve signals and cell volume. 4 roots, 1 membrane. Let's see which column actually does the work. Protein column first. No for simple diffusion, then yes, yes, and yes. Now the ATP column. 0, 0, 0, 1. 3 of the 4 use a protein. Only 1 spends ATP. A test that says yes 3 times in 4 is a coin flip. Direction, though, down, 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 up. It matches the ATP column exactly, every row. The second trap runs the rule backwards. High to low isn't uphill. It's the free direction. So lock it in. High to low is downhill, passive, free. Low to high is uphill, active, ATP. Which is why pumping potassium into a cell already full of it is uphill. Toward the crowd is always uphill. The whole decision is one question deep. Which way is it going? The rest is just naming the route. Look what that pump has been building. A pile of sodium outside the cell. A charged battery. So the cell puts a second protein next door and lets the sodium fall back in. The fall drags glucose up with it. Glucose went up its gradient, so this is active transport. And this protein hydrolyzes no ATP. The ATP was already spent by the pump next door. That's what secondary means. The bill came to a different desk. On the exam, read past the hardware. Through a carrier protein tells you nothing. Higher to lower tells you all. Down the gradient, free. Up the gradient, ATP. The protein is never the answer to the question asked. Want to step through this one yourself? Links below.